Hello everyone, in this video we're going to review Unit 10 topics 10.11 to 10.15 Taylor and Maclaurin Series. Alright, question 1. The coefficient of the third degree term in the Taylor series for f of s equals lns, center about s equals 1. Alright, so remember we have the Taylor series, center at c. C in this situation is 1, right? Now, the question wants you to find the coefficient of the third degree. Alright, so the third degree is going to be right here, because you have this guy right here, right? Now, coefficient, which means you only need this guy. Alright, so we're going to take the third derivative of this function, right? So we have f prime of s is going to be 1 over s is going to be s power of negative 1, right? Now f double prime of s is going to be negative s power of negative 2, right? And f triple prime of s is going to be 2 s power of negative 3, right? Now we're going to substitute the center right here, right? So it can be f triple prime of 1 equals 2, right? So the coefficient is 2 divided by 3 factorial, which means 2 over 6, which is 1 over 3. So the answer must be D, right? Now let's move on to question 2. What are all values of s for which the series converges? Alright, so we're going to use the ratio test, right? So we have limit of absolute value of a sub n plus 1 over a sub n when n approaches infinity, right? Now this guy right here is a sub n, right? So a sub n plus 1 equals s minus 1 raised to the n plus 1 over n plus 1, right? So I have limit when n approaches infinity, absolute value of s minus 1 raised to the n plus 1 over n plus 1 times reciprocal of this one is going to be n over s minus 1 raised to the n, right? Now we're going to simplify this one, so it can be limit when n approaches infinity, right? The top and this guy cancel out, we have s minus 1 on the top, right? We need to rewrite this guy and this guy, right? So it can be over n plus 1 times n, right? Now I can bring absolute value of s minus 1 outside. Then I'm going to take limit of n over n plus 1. So we're going to use the relative growth rate, right? We can cross out 1, right? So n over n is going to be 1, right? So final answer is absolute value of s minus 1, right? Now in order for this series to be convergent, this guy must be less than 1 by the ratio test, right? So this guy is the same thing as s minus 1 less than 1 greater than negative 1, right? Now we're going to add 1 3 sides, so it can be 0 less than s less than 2, right? Now we need to check the endpoints, right? S equals 0, substitute 0 for s back to the original one right here. So we have the series negative 1 raised to the n over n, right? And this guy actually alternating harmonic series, right? And it's gonna be convergence, right? Now s equals 2. We have the series 1 over n. Then this one diverges by harmonic series, right? Finally, your answer should be 0 less than or equal to s less than 2, right? Now let's move on to question 3. If e to the s equals this guy, then this guy must be what? Alright, so remember you have the Taylor series for e to the s equals, if n equals 0, you have 1, right? N equals 1, you have s. N equals 2, we have s squared over 2 factorial. N equals 3, we have s cubed over 3 factorial, plus etc., right? Now e to the negative s square. So we just replace s with negative s square, right? So it could be 1 plus negative s square plus negative s square altogether square over 2 factorial plus negative s square altogether cube over 3 factorial plus etc. right? Equals 1 minus s square plus s to the 4 over 2 factorial, right? Minus s to the 6 over 3 factorial plus etc. right? So this guy turns out to be, you just replace s right here with negative s squared, right? So you have summation n go from 0 to infinity, negative s squared altogether raised to the n over n factorial, right? And this guy turns out to be the sum n go from 0 to infinity, negative 1 raised to the n s raised to the 2n over n factorial, right? I can rewrite e to the negative s squared equal this one, right? Now look at this one right here. The question asks you the summation of this one when n start from 1. This one start from 0, right? Look at this guy right here. It's going to be the same thing already, right? So if I start this one from 1, does that mean I have e to the negative s squared equals, so I need to change this one to 1, right? So it could be summation n equals 1 to infinity of negative 1 raised to the n s raised to the 2n over n factorial, right? And if n equals 0, I substitute 0 for n. That gives me the answer 1, right? So I'm going to add 1, right? So I'm going to subtract 1 both sides. So I have e to the negative s squared equals summation n start from 1 to infinity, negative 1 raised to the n s raised to the 2n over n factorial, right? So the answer must be D. Now let's move on to question 4. The power series e to the s equal this one. Let f be the function given by fs equal e to the negative s squared over 3. Find p4 of s, the 4-degree Maclaurin polynomial for fs, right? So Maclaurin, which means the center equals 0, right? And p4 of s, the 4 degrees, right? So the highest degree should be 4, right? So we're going to look at this one. E to the s equal this one. We need to find e to the negative s squared over 3. So we replace s with negative s squared over 3. So we have p sub 4 of s equals 1 plus negative s squared over 3, right? Plus negative s squared over 3 altogether square over 2, right? We're gonna stop right here because if you take s squared and then you square, it's gonna be s to the 4, right? So we simplify this one. It's gonna be 1 minus s squared over 3 plus s to the 4 over 3 squared equals 9. 9 times 2 equals 18, right? Now question B. Write fs as a power series using summation notation. Alright, so we have e to the s equals, we just rewrite this one as a power series, right? So it can be the sum n start from 0 to infinity, right? Look at this one. This is s squared over 2 factorial, s cubed over 3 factorial, right? So it could be s to the n over n factorial, right? And then e to the negative s squared over 3 is going to be summation notation n start from 0 to infinity of negative s squared over 3 raised to the n over n factorial, right? You just replace s with negative s squared over 3, right? So we're going to simplify this one. So it can be summation notation n start from 0 to infinity, right? Now 3 raised to the n, and bring this guy to the bottom, right? And then I have negative s squared raised to the n. It's going to be s raised to the 2n, right? And I have negative 1 raised to the n. I put negative 1 right here, raised to the n, right? And this guy actually alternating series, right? Now, question C. Use the polynomial p sub 4 of s in part A to approximate f of 0.3 to 5 decimal places, right? So we have f of 0.3 approximately p sub 4 of 0.3, right? So it could be this guy right here equals 1 minus 0.3 square over 3, right? Plus 0.3 to the 4 over 18, right? Now I'm going to bring up the calculator and then press Ctrl Enter. Now it's going to be 0.97045, right? Now let's move on to question D. Find the interval of convergence of the power series for fs about s equals 0. Show the analysis that leads to your conclusion. Alright, so we're going to use the ratio test, right? So we have limit absolute value of a sub n plus 1 over a sub n when n approaches infinity equals limit a sub n plus 1, right? So we have negative 1 raised to the n plus 1 s raised to the 2 parentheses n plus 1, right? Over 3 raised to the n plus 1 times n plus 1 factorial. Multiplied by this one reciprocal, so it's going to be 3 raised to the n times n factorial over negative 1 raised to the n s raised to the 2n, right? Now we're going to simplify this one. Negative 1 raised to the n plus 1 can be written as negative 1 raised to the n times negative 1, right? This guy cancel out, right? So you have negative 1 left. When you take absolute value, it's going to be positive, right? So I don't need to worry about this one much, right? Now s raised to the 2 times n plus 1 becomes s raised to the 2n plus 2. Alright, so it could be s raised to the 2n times s squared, right? So this guy cancel out. We have s squared left, right? Now 3 raised to the n and 3 raised to the n plus 1, we have 3 on the bottom, right? N factorial and n plus 1 factorial, we have n plus 1 on the bottom, right? And we have the limit right here, n approaches infinity, take absolute value of this one, right? So when n approaches infinity, this guy approaches infinity on the bottom, right? So it could be 0 less than 1, right? So by the ratio test, this series convergent, right? For all real numbers, right? Let's move on to question E. For what value of n will absolute value of f of s subtract b sub n of s less than 0.0001, right? Now look at the question B right here. And this guy is the alternating series, right? So we need to use the alternating series error bound, right? So we have absolute value of f of s minus p sub n of s, right? Always equals the remainder, right? And this guy always less than or equal to the first omitted term, which is a sub n plus 1, right? Now you have a sub n right here, right? So a sub n plus 1, you just put 1 right here and 2n plus 1 right here, right? So we have, now we're going to check n equals 1. We have absolute value of f of s minus p sub 1 of s, right? This guy less than or equal to, substitute 1 for n over here, right? So I have 1 plus 1, it could be 2, negative 1 square, it could be 1, right? And absolute value of s raised to the 2 times 2, it could be 4, over 3 square, it could be 9, right? Times 2 factorial, it could be 2, right? So it could be absolute value of 0.3 to the 4, right? Over 18, right? So I'm going to print up the calculator. The answer is 0.00045, right? Now we need the answer to be less than this guy, right? But this is not right, so this is not correct answer, right? Now n equals 2. We have absolute value of f of s minus p sub 2 of s less than or equal to. So I have negative 1 raised to the third. It's going to be negative 1. When you check absolute value, it's going to be positive, right? Now, substitute 2 for n right here. So it could be 2 plus 1, it could be 3. 3 times 2 could be 6. So s power of 6 over 3 power of 3, right? Times 2 plus 1, it could be 3. 3 factorial, it could be 6, right? So it's going to be absolute value of 0.3 power of 6 over 3 cubed times 6. And I'm going to print up the calculator and press Ctrl Enter. It's going to give you 0.00000045, right? And this guy actually less than 0.0001, right? So the least positive integer is n equals 2, right? Now let's move on to question 5. For s between negative 1 and 1, if f of s equals this one, then we need to find derivative of this one, right? So basically, we just use the power rule, right? So we have summation notation and go from 1 to infinity. Negative 1 raised to the n plus 1 rewrite, right? Now, over 3n minus 2, you just rewrite, right? Now, you just print this one to the front, right? So, it's going to be 3n minus 2 times s raised to the 3n minus 2 minus 1 is going to be minus 3, right? Now this guy and this guy cancel out, so the answer must be B, right? Now let's move on to question 6. We need to find the power series for sine of 2s, right? Alright, so this one is sine of s equal this one, right? Now sine of 2s, you just replace s with 2s, so it can be 2s minus 2s cubed over 3 factorial, right? Plus 2s to the 5th over 5 factorial minus 2s to the 7th over 7 factorial plus etc. plus negative 1 raised to the n minus 1 times 2s power of 2n minus 1 over 2n minus 1 factorial, right? So the answer must be B. Now let's move on to question 7. Consider the power series f of s equal this one. For what values of s does the series converge? Alright, so we're going to use the ratio test, right? So we have limit when n approaches infinity of absolute value of a sub n plus 1 over a sub n, right? This one must be less than 1, right? So we have limit when n approaches infinity, absolute value of a sub n plus 1 is going to be negative 1 raised to the n plus 1 times 2 raised to the n plus 1 times s minus 3 raised to the n plus 1 over n plus 1 is going to be n plus 2, right? Times this one reciprocal is going to be n plus 1 over negative 1 raised to the n times 2 raised to the n times s minus 3 raised to the n, right? Now we're going to simplify. Negative 1 raised to the n plus 1 can be written as negative 1 raised to the n times negative 1, right? So this guy cancel out. We have negative 1 left. When you check absolute value, it's going to be positive, right? Now 2 raised to the n plus 1 and 2 raised to the n cancel out. So we have limit when n approaches infinity, absolute value of, you have 2 left on the top, right? Now this one n plus 1, so it can be times n plus 1. The border is n plus 2, rewrite n plus 2, right? S minus 3 raised to the n plus 1 and this one cancel out. You have s minus 3 left on the top, right? Alright, so I have absolute value of s minus 3 right here. I need to print it to the front, right? Because it's not related to this guy, right? Now, when n approaches infinity, this guy right here approaches 2, right? So we have 2 times s minus 3. This guy must be less than 1 in order for the series to be convergent, right? So it's going to be absolute value of s minus 3 less than 1/2, right? Or negative 1/2 less than s minus 3 less than 1/2, right? We're going to add 3 signs, right? So it could be. Now, we need to check for the endpoints, right? If s equals 5 over 2, we substitute 5 over 2 for s back to this one right here, right? So we have the series and start from 0 to infinity, negative 1 raised to the n, 2 raised to the n, 5 over 2 subtract 3 is going to be negative 1/2 raised to the n over n plus 1, right? So to simplify this one, it's going to be the series n start from 0 to infinity. Negative 1 raised to the n and negative 1 raised to the n is going to be negative 1 raised to the 2n, right? Now I have 2 raised to the n, I bring it to the bottom, right? Right here. And I have 2 raised to the n on the top right here, right? And the bottom I have n plus 1, right? Because this one can be written as negative 1 raised to the n over 2 raised to the n, right? So this one cancel out, right? Negative 1 raised to the 2n is going to be positive 1, right? So the series becomes n start from 0 to infinity of 1 over n plus 1, right? Now, I'm going to start from 0, I get this series, right? If I start from 1, what happens? So I just rewrite this one as the series ends go from 1 to infinity. Does that mean this guy becomes 1 over n, right? And this guy actually harmonic series, and it's going to be divergent, right? If s equals 7 over 2, right? And then the series becomes n start from 0 to infinity, negative 1 raised to the n times 2 raised to the n times 7 over 2 subtract 3 is going to be 1/2, right? Raised to the n over n plus 1, right? So this series becomes n start from 0 to infinity, negative 1 raised to the n times 2 raised to the n. Now this guy becomes 1 raised to the n over 2 raised to the n, right? So I have 2 raised to the n right here times n plus 1, right? So this guy cancel out. So I have the series n start from 0 to infinity, negative 1 raised to the n over n plus 1, right? So I can rewrite this one as the series n start from 1 to infinity. This one start from 0, right? Now this one start from 1, right? So this guy becomes negative 1 raised to the n plus 1, and this guy becomes n, right? And this one converges by alternating harmonic series, right? So the final answer should be this guy right here, but you need to include the endpoint right here, right? So it could be 5 over 2 less than s less than or equal to 7 over 2, right? Now let's move on to question B. Let g be the function satisfying g of 3 equals 5 and g prime of s equals ls for all s, right? Write the first 4 terms and the general term of the Taylor series for g about s equals 3, right? So the function f of s is given by this one right here. We just copy this one down, right? Now g prime of s equals f of s, right? So we have g prime of s equals f of s, right? Now we need to find the function g, so we need to take antiderivative both sides, right? So we have g of s equals antiderivative of f of s ds, right? So we're going to take entire derivative of this one, right? Now look at this guy right here. They are constants, so I just rewrite this one, right? Now this one right here, I just use the power rule, right? So it's going to be s minus 3 raised to the n plus 1, right? Over n plus 1, right? So I'm going to combine n plus 1 and n plus 1 right here. It's going to be n plus 1 squared, right? Don't forget to add the constant c. Now we need to solve for c, right? So in order to solve for c, we need to use the condition right here. G of 3 equals 5, right? So we have substitute 3 for s, right? So we have g of 3 equals 5, right? And this guy actually, and when you substitute 3 for s over here, this guy right here becomes 0, right? Because 3 subtract 3 equals 0, right? So it could be c. So c equals 5. So I'm going to go back over here. I'm going to replace c right here with 5, right? So this one is the answer for the function g of s, right? Now the question wants you to write the first 4 terms, right? So we have g of s equals, and start from 0, substitute 0 for s over here, right? So we have negative 1 raised to the 0 is going to be 1, right? This one, 1, right? This one right here, you have s minus 3, right? N equals 1. You have negative 2 over 4, right? Times s minus 3 squared, right? N equals 2. You have 4 over 9 times s minus 3 cubed, right? N equals 3. We have negative 8 over 16 times s minus 3 raised to the 4 plus etc, right? And finally, don't forget to add the constant right here. Alright, so this one is the answer for the first 4 terms, right? Now question C. What is the interval of convergence of the power series for the function g found in part B? Alright, it's gonna be right here, right? So we're gonna use the ratio test, right? So we have limit of absolute value of a sub n plus 1 over a sub n when n approaches infinity. This guy must be less than 1, right? So we have limit when n approaches infinity, absolute value of a sub n plus 1 is going to be negative 1 raised to the n plus 1 times 2 raised to the n plus 1 times s minus 3 raised to the n plus 1 is going to be n plus 2, right? Over n plus 1 squared, it could be n plus 2 squared, right? Multiply by this one reciprocal, it's going to be n plus 1 square over negative 1 raised to the n times 2 raised to the n times s minus 3 raised to the n plus 1, right? Now we're going to simplify this one, so it could be limit when n approaches infinity, absolute value of this guy and this guy cancel out, you have negative 1 left, right? So when you take absolute value, it's going to be positive, right? Now 2n plus 1 and 2 raised to the n is going to be 2 on the top, right? Now n plus 1 square, right? The bottom is n plus 2 square, right? And you have this guy and this guy cancel out, so you have s minus 3 left on the top, right? S minus 3 is not related to this one, I bring it to the front, right? So I'm going to take limit when n approaches infinity, absolute value of 2. Now, when n approaches infinity, 1 and 2 right here doesn't really matter, right? So it's going to be n squared over n squared, right? So when n approaches infinity, this guy cancel out, you have 2 left, right? So it's going to be 2 times s minus 3 right here. We need this one to be less than 1, right? So this guy is the same thing as absolute value of s minus 3 less than 1/2, right? So it's going to be negative 1/2 less than s minus 3 less than 1/2, right? Or add 3 both sides, so it could be 5 over 2 less than s less than 7 over 2, right? Now we're going to check for the endpoints, right? First, s equals 5 over 2. The series becomes, now we're going to simplify this one. 5 over 2 subtract 3. It's going to be negative 1 over 2, right? So negative 1 raised to the n plus 1 over 2 raised to the n plus 1, right? So this guy turns out to be the series n start from 0 to infinity, negative 1 raised to the n times negative 1 raised to the n plus 1, right? Times 2 raised to the n over 2 raised to the n plus 1 times n plus 1 square, right? Now negative 1 raised to the n and negative 1 raised to the n right here is going to be negative 1 raised to the 2n, so it could be 1, right? So you have negative 1 raised to the first left, right? So it could be negative 1, right? So you have the series negative 1 over 2 raised to the n and 2 raised to the n plus 1 cancel out, right? So we have 2 on the bottom, right? Times n plus 1 square, right? N start from 0 to infinity, right? So I just rewrite this one as the series. I'm going to start from 1 to infinity. It's going to be negative 1 over 2 times n square only, alright? So I'm going to apply the p series, right? So p in this situation equals 2 greater than 1, right? So by the p series test, the series convergence, right? Now if s equals 7 over 2, I'm going to have the series n start from 0 to infinity, negative 1 raised to the n, 2 raised to the n, and 7 over 2 subtract 3. It's going to be 1 over 2 raised to the n plus 1, right? Over n plus 1 square. And it's going to be the series n go from 0 to infinity, negative 1 raised to the n times 1 raised to the n plus 1 times 2 raised to the n over 2 raised to the n plus 1 times n plus 1 square, right? And then it's going to be the series n start from 0 to infinity, negative 1 raised to the n left, right? 2 raised to the n, this one cancel out, you have 2 on bottom, n plus 1 square, right? Now I can rewrite this one as the series I'm going to start from 1 to infinity, right? So this guy right here becomes negative 1 raised to the n plus 1 over 2 times n square, right? So by the alternating harmonic series, this series right here convergent, right? So we're going to include s equals 7 over 2 and s equals 5 over 2, right? So your final answer must be 5 over 2 less than equal to s less than equal to 7 over 2. Now let's move on to question 8. Consider the function fs equal 4 over 3s plus 2. Find a power series for fs center edge s equal 3. Now if you remember the topic 10.15, you have similar problem, right? fs equal 4 over s plus 2. But this problem has a power series center edge 0, right? Which is Maclaurin series, right? This one, the center edge s equal 3, right? So in order to do this one, you do exactly the same thing as example number 1 in topic 10.15 right here, right? You need to rewrite the power series in the form of the sum of an infinite geometric series, right? A over 1 minus r, right? So I have f of s equals 4 over 3s plus 2, right? Now s equals 3, I need to convert this one into factor form. So I just subtract 3 both sides, right? So I have s minus 3 equal to 0, right? This one is the factor, right? So I need this one to be right here, right? So I have 4 over 3 right? Instead of s, I put s minus 3, right? Because center s 3. And then I'm gonna rewrite to, now I need to check to see if everything's unchanged, right? So when I distribute this one, I have 3s. Distribute this one, I get negative 9, right? So I just literally subtract 9, right? I need to add 9 right here, so everything remains unchanged, right? So keep that in mind. Now I'm going to simplify this one, so it can be 4 over 3 times s minus 3 plus 11, right? Remember, you need to rewrite this one in the form of the sum of an infinite geometric series, which is a over 1 minus r, right? Now 1 is in the front, right? So I need to flip this one. It's going to be 4 over 11 plus 3 times s minus 3, right? Now I need the subtraction side right here, right? This one addition side. So I just replace addition side with 2 negative side, right? So it could be like this. Alright, now I need this guy to be 1, right? So I need to divide the top bottom by 11, right? So this guy turns out to be 4 over 11 divided by 1 minus negative 3 over 11 times s minus 3, right? So after I have this one, remember the series can be written as a sub k times r raised to the k, right? R is right here, and this one right here is the common ratio, right? So f of s can be written as the summation notation and go from 0 to infinity of 4 over 11, right? Times common ratio negative 3 over 11 times s minus 3 altogether raised to the n, right? Now let's move on to question B. Find the interval of convergence for your power series found in part A. Remember, the geometric series convergent if the absolute value of common ratio less than 1, right? So this one right here is the common ratio, right? So we need absolute value of negative 3 over 11 times s minus 3 less than 1, right? So this guy is the same thing as 3 over 11 absolute value of s minus 3 less than 1, right? Multiply both sides by 11 over 3. So I have absolute value of s minus 3 less than 11 over 3, right? So it's going to be s minus 3 less than 11 over 3 and greater than negative 11 over 3. Now I'm going to add 3 sides, right? So it's going to be negative 2 over 3 less than s less than 20 over 3, right? So the interval of convergence is right here, and it's your time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.